Okay, so I hope my screen, you can all see my screen?
Yeah,
Okay,
looks good.
excellent. Okay, so I'm going to be looking at the area of understanding symbiotic interactions and how CRISPR could be helpful around climate resilience. So let me just try and. Okay, so I really like this question that was posed to us, which is, what is the role of genomic innovation in addressing the next public health and food systems crisis, and what should we be doing now to prepare? And so, from an environmental perspective, I wanted to just create a framing for my remarks. And it's this idea of how do we look at driving knowledge-intensive strategies for resilience, thinking in terms of environmental framework. And it's this idea of going from knowledge to action. And so I'm going to flow in these three areas. First, exploring how using tools like CRISPR-Cas9 for more robust and specific gene knockdown, understanding soil microbiome related processes and deciphering plant microbe interactions for healthy and resilient ecosystems, and developing durable, eco-friendly and sustainable management strategies. So these are just examples in terms of we can use CRISPR in terms of engineering more robust crops, nitrogen fixation to end dependency on added fertilizers, hardy produce to prevent food waste, engineering plants to prevent methane emissions and fix more carbon, revolutionizing fundamental planet research. And this is the idea of, resilience requires sustainability. So how do we go about this? So innovation in genetic engineering is often targeted in response to evolving challenges. And so the issues we're always playing catch up. We've seen what happened over the weekend in terms of the new variant of COVID-19. So because of the ability to evolve constantly, we're always looking at how successful technology has to match the speed of virus adaptability for providing better and quicker solutions. So what really happens is we have siloed short-term targets and strategies. And this is inherently incompatible with our interconnected global ecosystem. So if we consider genetic manipulation to enhance crop yields versus increasing understanding of resistance to inform nature-based solutions, we have on one side, address current yield needs and issues as they arise, and this is a very reactive way of going about it. And what we need is really shifting timelines and mindsets, looking at long-term system sustainability, deepen and broaden scope of understanding, promoting enabling conditions, and being more proactive in terms of how we're using technology. So in terms of understanding soil microbe-related processes and deciphering plant microbe interactions for healthy and resilient ecosystems, on one hand, we have gaps to explore, and we also have an overarching theme that can be looked at. And so exploring the gaps. So first, one of the elements that I think is really important is how do we connect the genetic engineers and molecular scientists with the ecologists in terms of looking at this from a systems point of view. How do we contextualize high precision technology with cooperative ecosystems and bring in transdisciplinary points of view to see how are we using technology effectively to support the challenges that humanity faces, and refocusing. Much of CRISPR technology really currently focuses on engineering desired outcomes within the ecosystem, drought-resistant crops, increased nitrogen fixation. But shifting from engineering to identifying and connecting to nature-based strategies is something that could be looked at more. Another example is we focus on net zero is taking focus away from what we really need to do in terms of having healthier soils that prevent drought and flooding and allowing us to adapt to climate change. So there's a need to shift from targeting emissions goals to promoting nature-based mitigation and adaptation. And this idea of an overarching theme for me is really around interconnectedness. So I just want to give an example of the global risks work that has been done from a scientific point of view from the Future Earth Network, and the World Economic Forum has been looking at in terms of potential synergistic risks that can lead to global systemic crises. And so challenges do not occur in silos. What we know is that increased synergy among global risks also increases global systemic crises. And for how can we look at CRISPR in terms of a tool for understanding, connecting it to the holistic perspective within a larger system wherein the parts are responsive and exist in reciprocity as the whole? And so how do we look at crop resilience, not only in terms of what do we engineer in the crop, but in terms of how do we look at planetary resilience and see the crop as a model within that space? And so one of the things that is really important is how do we associate resilience within the sustainability framework? So this idea of how do we connect, contextualize, and refocus with a lens of interconnectedness is really critical. And I just want to just get back in terms of this global risk perception. So this is work we're doing, and we'll be launching a report December 13th, if that's of interest for anybody. I will share more information in the chat later. So one of the things for me is, if we look at the needs around the world in terms of what does it mean for resilience for human food environments, on the one hand, we can engineer crops, but how do we look at systems? And this is an example I just want to share in terms of the Chad River, where it's gone down in size between 1963 and today by 10 times, while the population has gone from 3 million people to almost 17 million people. And so the idea of how are we going to look at climate alone in terms of what we can engineer really needs to look at the whole spectrum of climate conflict trap and how are these interacting together. And so the importance of how we look at nature-based solutions in terms of a systems point of view and how CRISPR comes along is really critical. And the situation in Chad has really forced local people to really think about how they can solve solutions on their own. And what we've seen is that local innovation strategies based on indigenous traditional knowledge that look at the symbiotic relationship of plants with the microbes in the soil have really demonstrated increases in crop yields by 500%. So it's important for us to remember within these systems, how do we really use CRISPR not as a substitute, but really as an element within this larger ecosystem of how do we look at developing durable, eco-friendly, and sustainable management strategies. And so the opportunities and challenges are really how do we promote a low carbon economy and look at transforming industrializations towards nature-based alternatives and nature-based infrastructures. And what we know is pathways for novel infrastructure can really be based on this plant microbe interaction and how this symbiotic relationship creates opportunities for ways we can look at biocatalysis to replace chemical-driven hydrocarbon infrastructure. And in terms of regenerative agriculture, how this can help in terms of reduction of greenhouse gas emission and promoting carbon sequestration. A lot of work and data is needed in terms of supporting how we do this. And I think there's a lot of place where research can help us elucidate these pathways and interconnections, and CRISPR can play that role, not necessarily in bringing out genetic edited crops, but in elucidating the relationships within the microbiome and plant interaction in terms of symbiosis and how we can really promote a low carbon economy. And also what we also know, previous slide around Chad, is indigenous knowledge can play a critical role in terms of how we move forward in terms of environmental resilience. So how could CRISPR be a tool alongside indigenous knowledge in terms of having scientific methodology evidence actually support the promotion of indigenous knowledge in sustainability research and innovation? And in
2 minutes.
Okay, great. 2 more slides. So indigenous knowledge systems, what we know is as part of a commitment to scientific integrity and knowledge evidence-based policymaking, this is, I think, is some exciting development, that the indigenous traditional knowledge, ecological knowledge has been formally recognized by the White House as one of the many important bodies of knowledge that can contribute to scientific, technical, social, and economic advancements in the US and our collective understanding of the natural world. How can CRISPR help us elucidate the why behind indigenous and traditional practices as a tool for knowledge action? And really, for me, it comes down to, if we look at the digital age we are in, is tools versus system. how do we essentially look at what can be essential actionable insights, where insights refer to knowledge gained by combining scientific, artificial, and collective intelligence. And these essential actionable insights are the priority knowledge levers needed to effectively implement policies and actions to achieve global sustainability. And it's this idea of how can CRISPR be used within a mindset of planetary intelligence as opposed to a siloed technology-driven mindset? And how can CRISPR also be used as a tool in living our interconnectedness within all of nature? And how do we shift innovation and research from being resource intensive to knowledge intensive, looking at this pyramid where the bottom is how do we ensure trust across all of society, and really use technology to support collective intelligence that helps us achieve planetary intelligence, to help us live within planetary boundaries. And so I'm just offering a perspective that looks at our interconnectedness and looks at the lens of symbiotic relationships between plants and microbiomes, and how can this be a way for using CRISPR as a technology to scale this idea of planetary intelligence. Thank you.